So Station 2, Part 2. All of these different ways of lifting a 100 gram mass by 1 metre used some sort of fuel or food, whether it was my Weetabix for breakfast or whether it was gas being burnt in a gas-fired power station. And it made no difference whether originally that had been used to stretch a spring and was then stored and then released to raise the mass up, or whether I was pulling down or lifting up. It all ends up using the same amount of food or fuel. And one of the key ideas about energy is that it is for doing calculations. It's a way of accounting rather than something which causes things to happen. So in physics we try never to explain why something happens using energy. That's not what energy is for. It's a way of accounting for how much food or fuel has been used, how much energy has been transferred from one store to another store. And we measure energy in joules, and 1 joule is the amount of energy that is transferred when a 1 Newton force moves through 1 metre. I'm lifting a 100 gram mass, that requires a 1 Newton force. So a 1 Newton force moved through 1 metre, even if it's done through energy that's stored in a spring, even if it's done in stages, lifting it by 50 centimetres and then by another 50 centimetres, in total the amount of energy transferred is 1 joule. A force of 1 Newton moved through 1 metre. And that is the definition of 1 joule.